You are thirsty. Not dangerously thirsty, just the kind of thirsty where your mouth is dry and you're thinking about getting a glass of water. And within the next few minutes, you will. You'll walk to a tap, or open a fridge, or pick up a bottle. The thought of not being able to do this is so remote from your daily experience that it barely registers as a real possibility. Now strip that away. You're somewhere unfamiliar. The water you brought is gone. There is no tap, no store, no bottle. Just you, a landscape you may not know well, and a body that will begin to show serious signs of dehydration within hours and will face life-threatening consequences within days. This was the baseline reality of every human being who ever lived before the modern era. Not an emergency, just Tuesday. And navigating it required a kind of knowledge about the natural world that most modern people have entirely lost. A detailed, precise, transmissible understanding of where water was, when it would be there, how to find it, and how to know whether it was safe. How did early humans do it? The answer involves biology, ecology, memory, and some of the most sophisticated environmental knowledge our species has ever developed. Let's get into it. Let's start with what the human body actually tells you about water. Because the first navigation system early humans had wasn't a map or a landmark, it was their own physiology. Thirst is the most obvious signal. But thirst, as a survival tool, has a significant weakness. By the time you feel thirsty, you are already mildly dehydrated. The sensation of thirst lags behind actual need. And in hot conditions or during physical exertion, conditions that describe most of early human life, this lag can be dangerous. A person who only drinks when thirsty in hot conditions is always slightly behind their actual hydration needs. Early humans in stable territories almost certainly developed what modern wilderness survival experts call proactive hydration, drinking at known water sources even when not yet thirsty, because they understood that their territory had limited water access points and that the next source might be hours away. This requires not just knowledge of where water is, but a forward-looking model of the landscape. Here is where I am, there is the next water. This is how long it will take to get there. That kind of spatial and temporal planning, knowing not just where you are, but where the resources are relative to where you're going, is cognitively sophisticated. And it almost certainly developed, in part, because of the pressure to manage water access in environments where water was scarce or seasonally variable. The second layer of water-finding knowledge involves reading the landscape. And here is where traditional ecological knowledge becomes extraordinary. Animals need water too, and they show it in ways that early humans learned to read with precision. Birds, in many arid regions, fly toward water in the morning and away from it in the evening, because they roost near water at night and fly out to feed during the day. Watching the direction of bird flight, especially in the hours around dawn and dusk, can indicate the direction of the nearest water source. This is documented knowledge in traditional cultures across Africa, Australia, and the American Southwest. Certain animals are almost never far from water. Frogs and toads require water to breed and rarely range more than a few kilometers from a permanent or semi-permanent source. Finding a frog, hearing a frog, in an arid landscape is a strong signal that water is relatively nearby. Following the sound of frogs in the evening has been documented as a traditional water-finding technique across multiple cultures. Insects, too. Bees need water and typically don't range more than a few kilometers from a source. A dense concentration of bees, especially flying in a consistent direction, is interpreted in traditional knowledge systems as a water indicator. Certain fly species breed in wet conditions and can indicate the presence of water or dampness even underground. Plants are perhaps the most reliable long-term indicators. In arid regions, vegetation is concentrated along drainage channels, near underground water, or in low-lying areas where water pools. The presence of certain plant species is so strongly associated with water that their appearance alone is diagnostic. Cottonwood and willow trees in North American desert environments almost always indicate water within a few meters of the surface. Certain palm species in African deserts indicate underground water. reeds and rushes indicate standing or flowing water. Traditional knowledge of which plants grow only near water and which ones can be found in dry areas is a detailed botanical map of where water is and isn't. Researcher Sylvie Poutot at the Swiss Federal Institute for Forest, Snow, and Landscape Research has documented how traditional plant knowledge systems in arid regions encode precise information about water availability, often in ways that are more locally accurate than any generalized geographic knowledge. The plants themselves, in effect, serve as a real-time indicator of subsurface water availability that no map or satellite image can match in local precision. Beyond plants and animals, the landscape itself carries water information. In arid regions, water flows downhill and collects in low points. Dry riverbeds, wadis in Arabic, arroyos in Spanish, often have water just below the surface even when they appear completely dry. Digging in the sand of a dry riverbed, especially in a low point on the outer bend where water would have pooled during the last flow, is a traditional water-finding technique documented across desert cultures worldwide. Rock formations concentrate water in predictable ways. Water seeps through porous rock and emerges at the boundary between porous and non-porous layers, springs and seeps that can be tiny but permanent. These are extremely valuable in arid landscapes and would have been memorized and named and transmitted as critical landscape knowledge. The knowledge of where a specific spring was, how reliable it was in different seasons, what conditions indicated whether it would be flowing or dry. This is the kind of specific, local, irreplaceable knowledge that traditional cultures accumulated over generations. There's also the question of what happens underground, because in many arid regions, the most reliable water is not surface water but groundwater, water accessible by digging. The Kalahari Bushmen of southern Africa, the San people whose tracking knowledge we've discussed in other contexts, developed extraordinary techniques for finding underground water in one of the most arid environments on Earth. One technique involves watching where certain animals dig, particularly jackals and some antelope species, who have learned to find subsurface water by smelling where moisture concentrates in the soil. Following the digging behavior of these animals, or observing where the soil is slightly darker or more compacted from animal activity, can indicate water within reach of a hand-dug depression. Another sand technique involves a plant called the bai plant, a desert tuber that stores large quantities of water in its roots. Finding and digging up bai plants provided direct water access in conditions where no surface water existed. This knowledge, which specific plants store water, where they grow, how deep the tubers are, what time of year the water content is highest, is the kind of detailed botanical knowledge that took generations to accumulate and was treated as genuinely precious. Aboriginal Australians developed similar techniques for finding water in one of the driest continents on Earth. Knowledge of soakages, places where water seeps slowly into shallow depressions in rock or soil, was encoded in songlines and transmitted through the same narrative systems that encoded other landscape knowledge. A specific song might include information about the location of a reliable soakage, the landmarks that led to it, and the seasonal conditions under which it would contain water. To know the song was to know where water was. But finding water is only half the problem. The other half is knowing whether the water you found is safe. This is a question that has enormous survival implications. Contaminated water, water harboring bacterial pathogens, parasites, or toxic concentrations of minerals can make you severely ill and potentially kill you faster than dehydration would. And in the wild, the difference between safe water and dangerous water is often not visually obvious. Early humans developed several traditional indicators for water safety, some of which have genuine basis in environmental science. Running water is generally safer than standing water. This is because flowing water dilutes contamination, has higher oxygen content that inhibits some bacterial growth, and is less likely to have accumulated the mineral concentrations that make some still water toxic. Traditional knowledge systems across cultures prefer flowing water over still water when both are available, and this preference has real microbiological basis. The presence of healthy wildlife is a strong positive indicator. If animals are drinking regularly from a water source and appear healthy, it is a reasonable signal that the water is not acutely toxic. This is not perfect, Animals have different tolerances for various contaminants, but it is a genuine signal, and it is documented as a traditional water safety indicator across cultures. Smell and color provide negative indicators. Water with a strong sulfurous smell, a visible blue-green tint from algal bloom, an oily surface sheen, or an unusual color is recognized across traditional cultures as potentially dangerous. These are often accurate assessments. Sulfur indicates mineral contamination. Algal blooms can produce toxins. Oily sheens can indicate chemical contamination. Researcher Wade Davis, who spent years documenting traditional ecological knowledge across multiple cultures, has argued that traditional water knowledge systems are often more nuanced and more locally accurate than any generalized scientific framework could be. A San elder's knowledge of where water is in the Kalahari in February versus April, in a wet year versus a dry year, near this type of rock formation versus that one. This is knowledge that no textbook can encode because it is too specific, too local, too experiential. And it is knowledge that could be, and frequently was, the difference between life and death. The stakes of water knowledge failure were not abstract. Groups that misread the landscape, that traveled too far from water on the assumption that a source was closer than it was, or that drank from a contaminated source without recognizing the risk, paid immediately and severely. This creates an extraordinarily powerful evolutionary and cultural selection pressure for water knowledge. Groups with better water knowledge survived. Groups with worse water knowledge didn't. Across hundreds of thousands of years, this pressure accumulated into the extraordinary traditional ecological knowledge about water that we find documented across the world's desert and semi-arid cultures. There is one more dimension of this story that I want to explore before we close: the social and emotional significance of water in early human groups. Water was not just a resource, it was a gathering place. Water sources, rivers, springs, water holes were where groups met, where alliances were formed, where conflicts were resolved, where information was exchanged. In arid environments especially, the water hole was the social center of life in a way that has no equivalent in water-rich modern urban environments. The knowledge of water sources was therefore not just survival knowledge but social knowledge. Knowing where the water was meant knowing where people would be. It meant knowing where to find allies in hard times, where to negotiate access in times of scarcity, where to look for missing group members who would predictably gravitate toward water. In traditional cultures that live in arid environments today, the knowledge of water sources is often treated as one of the most closely held and carefully managed forms of social capital. Access to water is access to life, and the people who know where it is hold a form of power that is fundamental to the group's existence. This social dimension of water knowledge means that the transmission of water knowledge was not merely practical, it was political, spiritual, and deeply personal. The elder who taught a young person where the reliable springs were, which dry riverbeds hid subsurface water, which plants to look for in a drought. That elder was giving that young person one of the most valuable things a person could receive: the knowledge to survive. The next time you turn on a tap, or drink from a bottle without thinking about it, you are exercising a privilege so new in human history that our species spent the vast majority of its existence without it. Every ancestor you have, going back tens of thousands of generations, had to find their water, had to know where it was, how to get to it, whether it was safe. And they did. Across every desert, every savanna, every dry season that should have killed them, they found it, and then they taught someone else where to look. If this one changed how you see the water in your glass, you know what to do. I'll see you in the next one. There's something else worth naming directly: the physical experience of finding water after serious need. The experience of being genuinely, dangerously thirsty and then finding water is one of the most profound relief experiences the human body can have. It is not like satisfying ordinary thirst. It is a full-body response, the relief of immediate drinking, the gradual restoration of cognitive function, the emotional release that follows genuine fear. Early humans who survived serious water scarcity would have experienced this relief repeatedly. And the memory of where the water was that saved them, the specific spring, the specific dry riverbed with water below the surface, the specific plant that could be dug for moisture, would have been burned into memory with extraordinary clarity. Survival experiences create vivid, durable memories. The emotional intensity of the experience ensures the information is retained. This suggests that traditional water knowledge was not only transmitted deliberately, through instruction and story, but was also individually reinforced through the experience of genuine need and relief. The young person who was told by an elder where to find water in a dry season and then found it there, saved by that knowledge, would remember that location for the rest of their life. The knowledge wasn't just intellectual, it was emotionally anchored by the experience of survival. Researcher Lynn Kelly at La Trobe University in Australia has documented how traditional knowledge systems encode survival-critical information, including water source locations, in emotionally powerful narrative and ritual contexts precisely because emotional intensity enhances memory retention. The song that encodes a water source location is not just a mnemonic. It is an emotionally charged connection to survival experience that makes the information unusually durable and unusually resistant to being forgotten. And there is one final thing about water knowledge that I think deserves to be said. The knowledge of where water is in an arid landscape is not a list. It is not a database. It is a relationship, a deep, ongoing, reciprocal relationship between a group of people and a specific landscape that develops over generations and is continuously updated by experience. The water sources in a territory are not static. They change seasonally, they change with rainfall patterns, they change with ecological shifts, they occasionally dry up and are replaced by new sources. Maintaining accurate water knowledge requires continuous engagement with the landscape, paying attention, updating understanding, transmitting changes to the next generation. This is what traditional ecological knowledge actually is at its core. Not a fixed body of information, but a living, adaptive, continuously updated relationship with a specific environment. The knowledge is not separate from the people who hold it or the landscape it describes. It exists in the connection between them. Modern water infrastructure is extraordinary. It is one of the great achievements of human civilization, but it has also, for many people, severed that connection, the ancient, intimate relationship with the specific landscape that provides water. The knowledge of where water comes from, how it gets there, what makes it safe or unsafe, what seasons bring more, and what seasons bring less. For most of human history, this was essential knowledge. Now it is invisible. The people who found water in the wild were not primitive. They were expert. They were the product of generations of accumulated knowledge about a specific place, transmitted with care by people who understood that this knowledge was literally the difference between life and death. We are downstream of all of them, in more ways than one. Let me also talk about something that rarely gets discussed in the context of water finding. The role of memory, specifically, the extraordinary spatial memory that early humans developed to track water sources across large territories. In arid regions of Africa and Australia, where water is scarce and seasonally variable, traditional hunters and gatherers routinely maintained accurate mental maps of water sources across territories that could span hundreds of square kilometers. Not just the location of each source, but its reliability, its seasonal patterns, its quality, its accessibility, and its relationship to other sources. This is an enormous amount of geographically organized information, held entirely in memory, updated continuously through experience, and transmitted through story and song. Researcher Nils Burenholt at Lund University, who has studied the spatial language and landscape knowledge of the Jahai people of the Malay Peninsula, found that their vocabulary for landscape features, particularly water-related features, is extraordinarily detailed and precise. They have distinct terms for different types of water sources that would be collapsed into a single word in most other languages. Flowing versus still, permanent versus seasonal, surface versus seeping, safe versus potentially dangerous. This linguistic precision is not coincidence. It reflects cognitive precision that was shaped by the need to make accurate distinctions that had survival consequences. The San people of the Kalahari have similarly precise vocabulary for water-related landscape features, and their spatial memory for water locations across their territories has been documented as extraordinary by multiple researchers. They can describe water sources that haven't been visited in years with accuracy verified by satellite data. The memory is not declining with age in the way that incidental memories do. It is maintained with remarkable fidelity because it was forged under conditions where its accuracy mattered enormously. This kind of memory is not a special gift possessed by a few remarkable individuals. It is a capacity that develops in response to need, through practice, across generations of people who had no choice but to know where the water was. We are capable of it. We have simply not needed it, and have therefore not developed it. The ancient relationship between early humans and water was not one of mastery. It was one of dependency, attention, and respect. The water was there before they were, would be there after they were gone, and required nothing of them except the humility to pay attention. They did. And because they did, we are here.